We will find the third derivative of the function defined by g of x is equal to negative 4x squared e raised to the x plus 5x e raised to x minus 10 e raised to x. Now, since we know that e here stands for a Euler number with a particular value, we could say that the 4x squared is the first part of the function, while the ex is the second part of the function. So we will use the product rule to get the derivative of the function for the first part, and 5x raised to the x is also, we will use the product rule for the second part, and the 10 e raised to the x, which is a constant multiple rule, will apply here. Okay, let's solve. Okay, so the first derivative of the function g of x is equal to negative 4x squared, and that's the first part. That's the derivative of the second function, which is e raised to the x, plus the second function times the derivative of the first function. So the first function is negative 4x squared, so the derivative of that is negative 8x. This is the first part. How about the 5x times e raised to the x? We will get the derivative using the product rule, which is the first function times the derivative of the second function, e raised to the x, which is itself, plus the e raised to the x times the derivative of 5x, which is 5, minus the 10 times the derivative of the e raised to the x, which is e raised to the x itself. Okay, we will solve negative 4x squared times e raised to the x minus the negative 8x e raised to the x plus 5x e raised to the x, that's negative 3x e raised to the x, and 5 e raised to the x minus 10 e raised to the x, that's negative 5 e raised to the x. So to simplify that, that's e raised to the x times the quantity of negative 4x squared minus 3x minus 5. That's the first derivative. Okay, so we are way long to here. So we will get the second derivative of the function using the first derivative of the function. So e raised to the x times the negative 4x squared minus 3x minus 5. So the derivative using the product rule, so the first part, or e raised to the x times the derivative of negative 4x squared minus 3x minus 5. That's negative 8x minus 3. Plus the second function, negative 4x squared minus 3x minus 5 times the derivative of the first function, e raised to the x. So the answer for that is e raised to the x. It is already simplified, times the quantity of negative 4x squared minus 11x minus 8. This is the second order of the derivative. Now we will get the third derivative, which is what the problem is asking for. So the derivative of the second derivative, e raised to the x times the quantity of negative 4x squared minus 11 minus 8. That's e raised to the x times the derivative of the second part. So that's negative 8x minus 11 plus the second part, negative 4x squared minus 11x minus 8 times the derivative of e raised to the x, which itself. So the final answer is e raised to the x times the quantity of negative 4x squared minus 19x minus 19. So this is the third derivative and the answer of our given function. Another example here is the combination of trigonometric function and an exponential function. So f of x is equal to e raised to the x sine x minus 3e raised to the x cosine x. We will find the fifth derivative of the function. It's quite long. Okay, so to solve that, we'll get the first derivative of the function. So the first derivative, we will get the derivative of e raised to the x and sine x using the product rule. So e raised to the x times the derivative of sine x is cosine x plus the sine x times the derivative of e raised to the x. Next part is 3e raised to the x cosine x. So constant multiples rule, that's 3 times the derivative of, according to product rule, so derivative of e raised to the x times cosine x, that's e raised to the x times the derivative of cosine x, which is negative sine x, plus cosine x times the derivative of e raised to the x, which is itself. Okay, so we will combine like terms. So e raised to the x cosine x plus e raised to the x sine x plus 3 e raised to the x sine x minus 3 e raised to the x cosine x. So to factor that or simplify that, it's equivalent to e raised to the x times the quantity of 4 sine x minus 2 cosine x. So that's the first part, or the first order of the derivative. We'll get the second part. So e raised to the x times the quantity of 4 sine x minus 2 cosine x, we'll get the derivative, the second derivative, using the product rule. So a raised to the x times the derivative of the second function. So 4 times the derivative of sine x cosine x minus 2 times the derivative of cosine x is negative sine x, plus the second function 4 sine x minus 2 cosine x times the derivative of the first function e raised to the x, which is itself. So the answer for that is e raised to the x times the quantity of 2 cosine x plus 6 sine x. That's the second derivative. How about the third derivative? Using the second derivative, we will use product rule to get the third derivative. So product rule again, e raised to the x 2 times the negative sine x plus 6 cosine x plus 2 cosine x plus 6 sine x times the derivative of e raised to the x, which is itself. So the answer is e raised to the x times the quantity of 8 cosine x plus 4 sine x. This is the third order of derivative. We'll get the fourth order. Again, using the product rule, we will get the derivative of the third order to get the fourth order. So e raised to the x times the derivative of 8 cosine x, that's 8. The derivative of cosine x is negative sine x plus 4 times the derivative of sine x, which is cosine x, plus the second part, which is 8 cosine x plus 4 sine x times the derivative of e raised to the x, again, which is itself. So e raised to the x times the quantity of 12 cosine x minus 4 sine x. This is the fourth order derivative. We will get the fifth order derivative, which is what we are looking for. So using the fourth derivative, we will get the fifth derivative. E raised to the x times the 12 quantity of 12 times the derivative of cosine x, negative sine x, minus 4 times the derivative of sine x is cosine x plus the function, second function, 12 cosine x minus 4 sine x times the derivative of e raised to the x, which is itself. So the final answer is e raised to the x times the quantity of 8 cosine x minus 16 sine x, in which this is the fifth order derivative, which is the answer of our problem here. So that is all about the higher order derivatives. So we will switch to the next part of our topic, which is the chain rule.